And so, yeah, currently I run the artificial intelligence initiatives at OCP. So I don't know if you guys know OCP. It's a Moroccan-based company which is a leader in the fertilizer industry and in the phosphate industry in a more general way. And so, yeah, the name of my presentation is Analytics for Business: The Curse of Kaggle. And so, so it's a bit a provocative title, but for you guys who, I know some of you are quite geeks and really love machine learning and the history of machine learning, I guess all of you heard about the curse of dimensionality. And so the idea is that in machine learning, when you are in pretty high dimensions, all objects seems to be far away each other. And so it's a big problem if you want to train algorithm or if you want to work with big data in a more general way. And so, yeah, there is not any link between this problem and the Kaggle problem. But I was wondering, with my experience these last years, if at the end of the day, what I call the Kaggle mindset is eventually the new curse of machine learning. And that's why that's what I wanted to talk about today. So I guess all of you know what the Gartner Hype cycle for new technologies is. The idea is that when a new technology arrives in a market, initially you have a lot of expectation, and sometimes you have inflated expectation and you have too much expectation, and then people begin to be disappointed, and this is what Gartner calls the through of disillusionment, and people become disillusioned and are disappointed with this technology which seems so promising but under-delivered. And then we arrive at what we call a slope of enlightenment and the plateau of productivity. And so I showed you this diagram because a couple of days ago, I went to Google Trend, and I was wondering, like, what are the trends for the machine learning keywords? So I asked the algorithm for machine learning, data science, deep learning, and I was quite surprised because I saw that we reached the peak at the beginning of 2020. And since 2020, we can see a downward slope. And so I was wondering, eventually, are we beginning to enter the disillusionment phase? And so, of course, this is not a proof and correlation is not causality, but I wanted to explore this idea and to dig a little bit deeper. So the other problem is that the reason why I'm thinking about this disillusionment phase is because in my experience, when I talk with my friends who are also head of data science or head of AI, especially in traditional companies, in African companies, not in tech companies, I often hear that most of the projects fail and they don't deliver as much value as people expected. And even in the news and in the tech news, you often hear that 85% of data science projects fail and don't deliver value. And so the idea of this really short presentation is an attempt to understand the reason why we are facing this problem. And so I'm going to do a very quick, eventually too much quick history of machine learning in business context, because this is what interests me today, is how can we apply machine learning in a more general way, algorithmic thinking, in a business context, and what are the lessons that we can learn from the history. And one of them, actually, the first story that we often hear when we begin to be interested in machine learning is the Netflix prize. So I don't know if the audience knows, but Netflix 15 years ago was renting DVDs. So it was not the Netflix that we all know today. It was renting DVDs, and they had an internet web site where you could order some DVDs, and they had an algorithm named Cinematch, which could recommend DVDs for a specific user, given, of course, the history of ratings that the user gave when he was using the Netflix platform. And the idea is that the Netflix organized a competition in 2006, between 2006 and 2009, and the whole idea was to be able to predict the rating of a specific user for a specific DVD, taking into account the history of rating. So if you look at the data set that was used, it's quite simple actually. You only have the movie ID, the user ID, the date, and the ratings for the training set. And for the test set, you have the movie ID, the user ID, and the date. And the algorithm objective is to predict the rating that this specific user is giving for this specific movie ID. And so this is in some way the first Kaggle competition. And but if we look at the story behind, and I recommend for all of you guys who are quite curious about this story to look at the case study in Harvard Business School, in the Harvard Business Review, sorry. If you look at the Harvard Business Review website, they have a pretty big case study around the Netflix price story. And if you think about it, you have 4 steps in this story. The first is that the executives understood that the churn rate is one of the main KPIs to track, which is not straightforward, but well, you can understand it quite easily if you understand the way the DVD renting business works. So the churn rate is the main KPI. The recommendation system allows to reduce churn because if you recommend DVDs to people that they like, they tend not to churn, and so they begin paying their monthly subscription. And actually in step 3, they began to build the Cinemax software without any sort of machine learning. So you had algorithms behind, it was not machine learning, and it already delivered some value with this, with these simple algorithms. And then because this algorithm was already working, we have a quote from the CEO of Netflix, Reed Hastings, who was saying, if the algorithm could be improved by 10%, we could generate between $60 and $89 million in annual revenue over the next 4 years. So it's very interesting, but it's in the Netflix situation, an improvement of the algorithm could have pretty big financial impact. And so if you look at the leaderboard, sorry. So at the end of the competition, we had the leaderboard, and actually the winner of the competition succeeded to improve the algorithm by 10%. And so it was in 2009. And so like there was a consensus around the idea that algorithm can add a lot of value to companies through machine learning competitions. And so it's not so surprising that in 2010, Kaggle is created. And so for I guess all of you know Kaggle, but for people who don't know, it's basically supervised machine learning competitions with data sets whose structure is quite similar to the Netflix competition. So you have a table, basically. Sometimes most of the time it's numerical data. Sometimes it's images or sound, but it's usually supervised machine learning. So you have a target. You have a target that you want to be able to predict in a test set, and you train your algorithm in a training set. So basically, it's the same concept that in the Netflix prize, and you also have the leaderboards of those Kaggle competitions. And if you're curious and if you go to visit Kaggle website, you can see that the scores of the winning algorithms are really close to each other, and so that basically, if you take the 10 first people in the leaderboards, their algorithm is really, the performance of the algorithm is really similar to each other. And so this whole explosion of machine learning competitions, and in the more general way, the machine learning framework, where you have a data set and you have a target that you want to predict, and you try several algorithms, and you want to build the algorithm with the best performance, also led all the AI unicorns to propose AutoML features. So it was in the same, so it was following this history that we began to see Dataiku, DataRobot, H2O, 9, Amazon SageMaker, Google AutoML, which all propose basically, if you have a data set with a target value that you want to predict, with our tool, you can discover the best algorithm really easily. And their position was, we are AI unicorns, basically because one of our main features is the AutoML feature. And so you could think and you could wonder, so what's wrong with this machine learning competition or the machine learning, supervised machine learning framework? So what's wrong with it? So in my opinion, the reason why I can see it as problematic is because what the Kaggle mindset in non-tech companies, so in traditional companies, has some consequences. So of course, you have a lot of positive consequences. So Kaggle and all the data science competitions websites, they're great to understand machine learning concepts, They're great to understand the difference between training set, test set, overfitting, to manipulate data, to understand what feature engineering is. And it's also great because problems are really correctly framed and data sets have pretty good quality. And so the users can only focus on the algorithm building. And you also have a pretty big community of practitioners. So you learn a lot talking with other users. So they're great platforms, of course. But the problem is, usually in traditional business situations, a lot of problems are very ambiguous. And so they are not correctly framed. And it's very rare that you are in a business situation in a traditional company and that your main problem is to build the best algorithm. I mean, the Netflix situation actually is quite rare in traditional companies, again, not in tech companies. So, and the other problem is that the Kaggle phase, so in analytics projects, in some of them, you have to build a machine learning algorithm at the end. And actually this phase, what I call the Kaggle phase, is the easiest phase, especially now that we have all the AutoML tools. So this is not really the hard thing to do. And in traditional companies, it's very rare that a small improvement in the algorithm really leads to important financial gains, like in the Netflix situation. I mean, what the CEO of Netflix said in 2006, was very specific to the Netflix business. And the other thing is that actually in many analytics problems, actually machine learning is not a relevant tool at all. And you should use other quantitative tools. It can be operation research, it can be basic statistics. So the machine learning framework is not like universal. And so again, in some situations, especially for the big tech players, so like YouTube, Netflix, Spotify, Amazon, all these players, I chose like the most famous ones. For these players, the ML algorithms play a key role, and the performance of the algorithm can lead to really important financial gains. So if you think about it, like Amazon, if the recommendation systems of Amazon works slightly better, it means that millions of users will consume the same algorithm. And so a slight improvement of the algorithm can lead to very important financial gains. But it's because of the structure of these tech companies, where you have a software which uses already the algorithm, and you have millions of users every day that use basically the same algorithm. And so if you slightly improve, you have a big scale of impact, and you can have a lot of financial impact. And so this whole Kaggle mindset makes sense for these players, but for traditional companies, not so much. So because I just have 6 minutes left, and I want to be able to answer some questions if they are. But so the question is, okay, so for African companies, and most of them are not really tech companies, so they don't really sell software. Most of them are industrial companies, telco companies, or oil companies. What could be the best AI strategy? And so for me, in my humble opinion, I think the focus should be, if we had to take the Netflix example as an inspiration, we should focus on the step 1 to 3 in the Netflix story. So the idea is not to focus on the improvement of any algorithm, but it's much more to focus on what are the main KPIs of the business and what are the main processes that really are problematic for especially the operations of the business. How to build a first algorithm, quite simple algorithm, not necessarily machine learning, that already works, and see if a simple algorithm can already have an impact on the way the business works. So, and for me, the most important is not necessarily to have only a team of what we call now data scientists, but really a team of people who are able to translate business and operational problems into algorithmic problems. And I use the word algorithmic on purpose, because I don't think that machine learning can be used, of course, in any situation. So, and the idea is that for me, the most interesting part and the most complex part is the mathematical conceptualization of real problematics. So if you think about it, like for the most famous ones, how can you reduce churn in a telco company? It's through a classification problem to predict churn probability. How to create customer segments? It's the clustering algorithm. How to predict demand, it's a time series. How to reduce transportation costs, it's an operational research algorithm. So the idea is to have a team able to translate a pretty big diversity of operational and business problems into algorithmic problems. And so what you need to do it is not only to be able to do a Kaggle or to have a pretty good score of Kaggle, even if it's quite nice and it can be useful in some situations, but really the skills that are needed in my experience is a lot of creativity, because if you really need to understand the problem before thinking about any solution, is machine learning or deep learning or anything else, a pretty strong business understanding, and what I call algorithmic thinking. So the ability to translate and to conceptualize real life problems into abstract problems that are solvable through data and an algorithm. So I'm really sorry I was a bit long. So now I think we have 3 minutes if some of you guys have some questions.
Thank you very much for the talk. It was extremely insightful about all of these Kaggle competitions. We have a question regarding, so most of the data scientists in over the Kaggle competitions are focused more towards the accuracy and the measures and basically to go up in the leaderboard, right? What does this make regarding the explainability of the models? Because that is a topic that is, in my opinion, also is very important, but is ignored. And how does that reflect in terms of the data scientists that are working a lot on Kaggle in these competitions to basically advance in the leaderboard?
Yes, actually, it's another problem, because I focused on the eventual impact of these algorithms. So I was saying that if you're good at Kaggle, doesn't mean that you can have any impact on a company. But you're right, actually, there's another problem, is that even if you have an impact on a company, you should be able to understand what your algorithm does, and you should be able to explain to business executives how your algorithm works and the reason why you have these results, especially in some regulated industries, or if you think about HR or banking. I mean, if you give a loan to someone, or if you refuse to give a loan to someone, you should be able to explain why you don't want to give it to him. So, and Kaggle doesn't teach you that. It just teaches you to predict the future, understanding the past. It's a caricature, but like more or less.
Exactly. One other question is regarding how basically to compute the return on investment from a problem that is, for example, displayed on Kaggle.
So yeah, so the whole idea for me is also to bring this culture in the company. So the problem is that because it's easy to measure the return on investment, is just to say you have a situation and you compare before using the algorithm and after using the algorithm. Did you reduce the cost? Did you improve profitability? I mean, but at the beginning of the project, there must be some metric that you want to take into consideration to measure an eventual success of the project or a failure. And this is independent from the Kaggle mindset. In any digital transformation project, you should have some measures and some KPIs that you want to track to be able to know if what you did had an impact or not. So my point is, the idea is also that data scientists tend not to really care about the return on investment of their projects. And I would say it's more a cultural problem than a really technical problem. It's a long story. I just have 30 seconds left.
Yeah,
I won't be able to deep dive.
One last question from the audience is: are African startups able to use Kaggle strategies?
Well, they can do whatever they want. Actually, the only thing is, I was just wanted to underline the difference between the expectation on the financial and business impact of the Kaggle mindset on companies, between the expectation and the reality. So if these African startups really found a problem that they can solve with one algorithm, so if basically they are pure tech startups and that they are trying to solve a specific computer vision problem, for example, or healthcare problems, of course, the Kaggle mindset can really be helpful. But my presentation was really towards traditional companies and big African companies. If you take any African company, if you take the 10 biggest companies, usually they are not tech companies, they are not software companies. They are what I call traditional companies who are in a digital transformation journey. And the idea is that for them, they cannot use machine learning the same way that the GAFA players do. And the Kaggle mindset can be confusing for them. So they organize competitions and everything, but the return on investment is not necessarily here.